Okay, I'm going to start off with why I hate IoT. I don't mean the technology or the category. I mean the name, the label. It doesn't actually mean anything anymore. Everything is connected, so nothing is not IoT, unless you're talking about like raw materials or something. It's industrial IoT, it's smart home, it's smart cities, it's your car, it's your inkjet printer, it's the F-35 Joint Strike Fighter, it's pretty much everything. A small rant, but you know, it leads into, there we go. What is the rollout of IoT and where it's been going and where are we now? Now this slide might be a little difficult to parse, but the vertical axis is when an analyst was making his prediction. These are analyst predictions for the number of units of IoT installed in a particular year. And that's something we've been hearing about for years, all of us. This is not new to anybody, right? So in 2014 and 2016, there were estimates of anywhere from 25 billion to 50 billion units installed. And by the year, and that's the x-axis, by the year 2020, as many as 50 billion units installed worldwide. Okay, 2020, that's the beginning of the pandemic, right? That's 5 years ago. Where are we now? Well, in 2022, the estimates were now downgraded to 14.4 billion for 2022, maybe 27 billion by now. So how did we go from this raging growth of 50 billion to this less than raging growth of 27 billion by 2025? The previous estimate was for 2020. Okay. This paragraph is from the IoT Advisory Board report. The IoT Advisory Board was set up by Congress to work within the Department of Commerce. It's a bunch of private sector subject matter experts who came together and analyzed why IoT was not growing as quickly as it should and what the government could do to correct it. And the barriers to adoption that they cited in the report, I was on this committee, by the way, so I should say we. Upgrading legacy infrastructure. You think about how great it is that farmers have connectivity for their equipment and their sensors out in the fields, but getting 5G, getting 6G, getting Wi-Fi, getting Bluetooth, getting satellite to that North 40 isn't necessarily a done deal or built into the assumptions of growth. Managing enterprise silos. I think we're all familiar with the issues of siloing within our own organizations, particularly if you work for a larger organization, but this is a challenge. It's discussed in the report. Harmonizing technology and data and interoperability challenges. So this has to do with when you do a full implementation on a large project, let's say you're thinking smart city or an entire farm enterprise. You're probably going to be working with different manufacturers. Hopefully, you've only got one major platform doing the integration. You've got data coming in from different technologies. You've got different protocols trying to talk to each other. All of these integration challenges are a serious issue when people actually sit down, put pencil to paper, and try to get to work. Fragmented supply chains. I'll talk about that a little bit. Delivering end-to-end IoT solutions which require broad partner. Okay. End-to-end IoT, end-to-end solutions. At the one end, you might have, again, using the farmer as my example, you might have soil humidity sensors and watering systems, irrigation systems, and tractors that are GPS navigated, and all kinds of stuff going on. At the other end, you've got the full-on traditional enterprise IT challenges of protecting cloud data, integrating your systems on AWS, stuff like that. And so broad partnerships, diverse expertise required, and some of this is a workforce challenge as well. So the Internet of Things Advisory Board report is a couple hundred pages long. There's a link to it there. It's not a bad thing to look at. It's got an awful lot of source material cited, an awful lot of interesting recommendations for the government. That report actually goes to a working group of federal agencies that will look at how to reduce federal regulation or promote expansion through grants or other programs. Everything from the CHIPS Act implementation to workforce improvements. So there's things that the government can do. Anyway, that federal IoT working group is expected to deliver their report sometime soon. And it will include this IoT Advisory Board report from the private sector. Okay, so those were past challenges. All right, that's prelude. What are the challenges informed by emerging trends now? And if you look at this list here, this is a subset. I only have a half an hour, so I chose to talk about these things. I'm going to try to stay in my wheelhouse. But the unwritten elements here, macro factors that inform a list like this are national security concerns based on geopolitical situation. Artificial intelligence, not just generative AI, but all the elements, machine learning, the whole thing, that is now being built into IoT. Quantum computing, an emerging disruptive technology. So I'll talk about all of these. Let me start with supply chain. Supply chain is going to impact all of us. It's already impacting all of us. You saw it, for example, during the first Trump administration with the automotive sector really struggling with the impact of tariffs and trade war on the supply of legacy components. A car might have a 10-year-old or 15-year-old or 20-year-old chip in it. Maybe 20 years is a bit much. But the point is that they're not like an iPhone. An iPhone has chips that are designed for that model year primarily. And they don't have a problem with that. When they're looking at 7 nanometer processes, chip processes, that's the big business of a TSMC and others. I mean, this is 7, 14, 20. These are major nodes, and there's a lot of production capacity assigned. But the processors and voltage regulators used in cars in many cases are older technologies, and in 2020 through 2022, there were a lot of issues with the automotive sector getting those components because fabs were switching production away from the legacy components towards much more profitable devices that were more current. So we have a whole bunch of geopolitical issues wrapped up in this as well. Localization and tariffs and bans, oh my. Sorry, I might be, I don't know. Is anyone here young enough to remember The Wizard of Oz? Okay, so here's the deal. Localization, data localization affects IoT in that you may not be able to store your data where you thought. The platform people you're working with may not necessarily be providing in US data storage. And if that's the case, and there comes a push under the current administration to require in-country data localization, there's a problem. This actually started happening with GDPR in Europe, and so this is not entirely new. What's happening right now is that the current administration and Congress are possibly the least regulatory-friendly government, federal government structure that we've had in my lifetime, okay? And that's saying a lot. I mean, they would like to have as little regulation as possible. And this is not putting words in anybody's mouth. Just listen to the leadership right now. Okay. The stuff that's on this slide might be the exception. That's the thing to watch out for. So tariffs. Let's talk about tariffs briefly. This is all in the news. You don't need a lecture on tariffs at an IoT event. But let me just put something in perspective. This is difficult to read, the x-axis, but it's years 2005 out to 2021. So this is 15 years, 16 years, starting in 2005. So it's basically the first part of this millennium, this part of this century. And you can see most of this rots around the 1.7, 1.8% weighted mean all products being imported to the United States. Right? There was 1 year during the first Trump administration where it peaked, but for the most part, we've been down across the board all products averaged out at about 2%. But if you look at where this fits into the historical perspective, yeah, post-World War II, we've got relatively low tariffs, but historically, there's actually much higher tariffs. My point is, tariffs are not going to be good for anybody in terms of pricing, cost pricing, maybe even availability. You're going to be looking, you're already looking around at your suppliers. If you haven't already been for several years now, you really should be. But we've survived before. This is post-World War II, new stuff, but we can survive this. All right, bans. What about bans? Outright ban of product. Now, there's several bans in place right now. You cannot import a Huawei module, 5G module for your product, right? They're on the entity list, they're on the FCC's covered equipment list, so there are outright bans on certain companies or certain equipment. The FCC commissioner under President Trump right now, Commissioner Carr, I don't want to put words in his mouth, but I will tell you, don't be too surprised if he is in favor of further efforts in this direction. Okay? It's a situation where you want to be very careful. Again, I don't want to tell you not to buy, don't buy China. I'm not going to say that. That's ridiculous. But you do want to be careful about your supply chain. So all of this goes back to national security, concerns about the supply chain. Watch what you're doing. What can you do? Other than looking at your vendors and trying to make safe choices, there is actually an effort underway with regard to compliance to new rules. Now, I want to be very clear about something. Because there is a standard, because industry develops a standard, does not mean anyone has to comply. That's not what the standard is about. Standards are good for interoperability, but in this case, the HBOM standard that I'm going to talk about is good to help you comply if the government comes in and gives you a mandate. The problem we have is that someone in Washington who has never worked in industry, works for a senator, works for a representative, writes a bill, puts it in law, they get feedback from industry, they take some, they disregard some, and then we're stuck with the result. So what could happen? Well, you could be required, as happened with the Sarbanes-Oxley law in, years ago, to declare your supply chain is free of conflict minerals, right? For any publicly traded company, you have a requirement under law now to make sure that you have to certify that your supply chain is free from conflict mineral materials. Some of you may already be dealing with this much more than I do, and you may be able to correct my language, but that's the basic idea. So what does that mean? That means you have to be able to go to your supplier and their supplier and their supplier, if it goes back that deep, to the mine and show that the mine is not in Sudan or someplace where there is a conflict going on and the profits from the mine are being used to fund the conflict. So, do you and your suppliers have that kind of information framework in place for every chip, every place that chip has been designed, fabricated, assembled, put onto a module, the modules put onto boards, the sub-units stored, where they were stored, where this stuff was transited through, where data is stored for the product, all the way through. Can you do that? Because that is actually the requirement on telecommunications companies right now. So Verizon, for example, has that stuff in place. They go to their vendors and say, this is the format. You, vendor, have to supply us with information in this format. And then they have to go down their supply chain and make sure they're doing the same thing for the requirements at that level. They don't have to go to the mine because this isn't conflict minerals. But the point is that they do have to make sure that a chip design is not coming from an area declared off limits by the FCC. So that was actually some of the impetus in work on HBOM standardization. Hardware bill of materials. Everybody in the manufacturing world has a hardware bill of materials. How can you build without it, right? You have to know what's in your product. Well, the standardization effort is to give everybody a common language for that that includes the extra information I just mentioned about where the chip was designed and assembled and fabricated and all that. If you have all that information if the suppliers are able to provide it in the correct format, then you can import it into your bill of materials as you make a module. You can import that into your bill of materials as you make an assembly. You can provide that, if you make the unit, you can provide that stack of information all the way to the customer who's demanding that you comply, or in the private sector, or the government people that are demanding you comply. So this is a new effort. It just started up. Emily Hafer is a friend of mine. She's at NEMA. I would recommend emailing her if you want to get involved and help craft this standard. You can see the early version of it at CISA under HBOM framework, but right now the real action is coming out of NEMA as they standardize this. This will be an ANSI consensus standards body. It will therefore be an American national standard when it's done. Again, these are voluntary consensus standards when we talk about it this way. Tooling vendors, if you get your platform for your manufacturing component, your materials tracking and procurement, if you get that from somebody, you're going to want them to add and export in this format eventually. Anyway, that's an interesting program. I recommend checking that out. All right, let's talk about regulatory pressures per se. Vulnerabilities is kind of a bugaboo for me. I don't mean that I think that they're bad. Everybody does. I don't mean I think that attention to them is bad. Everybody should be paying attention to them. I mean that the way that they're handled by the folks in Washington can sometimes be a little bit awkward. What do? They will sit down and write a bill that says the IoT developer must address all known vulnerabilities. All right, what's known? A high school student puts it on a PowerPoint on stage in his commencement address. Is that known? Right? It's published in North Korea. Is that known? Well, we don't know until it goes to court and gets tested. Nobody wants to go there. So fortunately, there are routinely exploited vulnerabilities. This is not a language that's used in any draft bill or regulation I have seen, but CISA does publish this report. Now, what do you get from it? You get a long list of CVEs. These CVEs, coordinated vulnerability. This list has one highlighted. It's called Log4j. I don't know, does anybody remember Log4j? Does anybody? Yeah, I see a few hands. Yeah, Log4j rocked the world. Thousands of companies were impacted by this. And that one actually does apply to IoT people. Most of the stuff that you find in the CISA advisories is for enterprises, right? It's for your average, target IT department, some real estate company IT department. That's hospitals look at this stuff because their IT department needs to know about this stuff. There are currently something like 170,000 CVE vulnerabilities and other reports listed in the National Vulnerability Database. If you are an IoT developer or a manufacturer, or you're looking to comply, if this stuff touches you at all, cybersecurity touches you at all, and somebody's saying, well, what about vulnerabilities? Going through this list as an IoT person is daunting, right? I mean, hire a dozen interns and have them parse through 170,000 records. There is some filtering, but what we have recommended to CISA and NIST, and this is in that IoT Advisory Board report I mentioned earlier, is put in a filter for IoT. Right? If the vulnerability affects IoT, flag it. Let us know. Right? You've got this huge contingent of people working on these problems. Make it easy for them. It should not be that hard. So I've had a preliminary meeting with DHS people on the viability of this, the vulnerability management team at CISA. And they gave a relatively positive response, as much as they can. They're not leadership. They couldn't say, yes, we will do it. But basically, you may start seeing an ability to filter out vulnerabilities in IoT on the government sites. Let me talk. I'm staying a little bit with cybersecurity because it's a lot of what I do. And I have limited time, so I'm going to stay in my wheelhouse. But cybersecurity certification and labeling, there's a new program for consumer-connected IoT devices called the US Cyber Trust Mark, USCTM. The US Cyber Trust Mark is a program being stood up by the FCC at the urging of the prior White House. It looks like it will continue through the new administration. It's not one of the things that's currently getting pressure. The FCC is currently implementing it. The program kind of looks like this at the top level. I'm not going to go deep on this. I'll provide some resources at the end if anybody's interested, if you are doing consumer connected devices for smart home and other. But there's a concept. The concept is that on the package, on the box, there is an FCC mark of approval, this logo that looks like a shield with PCB traces in it, and a QR code. The QR code goes to online information. The first food nutrition label you see on the left is consumer-oriented information. The one on the right is technical information for security researchers, government agents, whoever, supply chain people, more technical stuff so that we can inform the ecosystem and do a better job. So a lot of industry people have helped put this picture together. Most of the work was done at CTA and NIST. When I say CTA, I mean we're an ANSI accredited standards body, and we have a number of standards groups that have been working on this. CTA is handing our piece over to UL now. UL will be the lead administrator of this program. We declined to bid on it because it's not really our gig, but it's a good fit for UL, and we're helping and encouraging UL to launch this program. So by the end of this year or early in 2026, you should be able to go into a Best Buy, Target, Walmart, look at a product, and sort between the ones that have this mark and the ones that do not. The ones that have this mark will have gone through third-party conformity assessment testing to make sure that they meet cybersecurity technical requirements. The foundation for this, if you're interested in looking it up, is NISTR 8425. That document will tell you a lot about what it's all about. I'm going to skip over this in the interest of time and just touch on what's actually in it. This is what's in that document. There are non-technical requirements for documenting your secure development lifecycle, the ability to receive a query about cybersecurity from a third-party researcher or other outside group, generally assumed to be the ecosystem, not the consumer. Information dissemination to two paths. One is to the consumer. If there's something that they really need to know about the cybersecurity of what's going on, maybe a big event, then you should be able to reach the consumer through web pages or other. The ecosystem. Can you reach researchers, developers, other people using the same library that you just found a problem in? Whoever else, suppliers, that's the other one. Suppliers, there's some more categories in there, but basically, can you reach the people who could benefit from knowing about a cybersecurity event or issue? And finally, product education and awareness. Do you have enough information on your website and other places so that the consumer can securely configure the device and basically know what the switches are and what they do? All right, asset identification leads off the technical requirements. Asset identification basically means that you can find the device on a network. If the device is installed on a network, you should be able to uniquely identify that instance. That's it. You just have to be able to find it. And so there should be some means that a network manager can go out and touch it. For the most part, consumers are not going to use this until it gets automated. I don't know too many of my friends and neighbors and relatives who have a network management console in their home, or if they do, that they know it. But asset identification leads off. There's product configuration. Can you securely configure the product? Interface access control. Are the interfaces in the product logical ones that you can reach over the internet, login type of things? And hardware interfaces like UART, JTAG, whatever, are they secured? Or are they points of opportunities for a hacker to attack? Are you protecting data? This is encryption, right? Are you using decent encryption? Not deprecated stuff. You're not using SSL 3.0, right? You're protecting data at rest and in transit. Can you update the software? Ideally, this would include crypto agility, and I'll talk about that in a little bit. But basically, you should at least be able to patch software, so when an exploit is found, you can go out and fix it. One of our huge challenges in the IoT world is, remember those anywhere from 14.4 to 50 billion units projections that I talked about? All of that, the vast majority of it does not have software update capability. So We have a huge, huge install base issue after this. Also, this is a United States only program. It's a voluntary program. There are mandatory requirements that are similar going in Europe, in India, China has some, a variety of others. Malaysia, Singapore has a sort of industry-leading one. But the attacks are coming from all over the world. And so the whole planet has this issue. And then finally, cybersecurity state awareness. Can you log data related to cyber issues like too many login attempts? Right now, there is an enormous flood of brute force password attacks going on, conducted by compromised routers in places like Brazil, Argentina, Russia, and they are trying to get into edge networking devices like VPNs, storage devices, things like that, by flogging the passwords. So multiple password attacks would be a great thing to know about. Okay, let me talk about quantum computing. Where does quantum computing affect us? Here's the thing. Quantum computing is famously flagged as potentially breaking the public key infrastructure that we use today. And this is a report that was done in 2021. The problem is we can't say exactly when this is going to happen. NVIDIA and Google have both gone public with comments over the past 2 months, actually past month, since CES. NVIDIA's Jensen Huang at CES made some projections that it would take longer, and Google came back and said, no, it's actually going to be earlier. But 2035 is kind of a rule of thumb that a lot of people are using, including the government right now. So the thing is, what are the threats from PKI being hacked? There's two that I want to flag here. One is called harvest now, decrypt later. Whatever data you're passing over the network, if someone is listening in, and that's not hard to do, and they're collecting the encrypted data, can they decrypt it once they have a quantum computer? That's a real threat. This is why enterprises are being urged to convert over to post-quantum secure encryption algorithms. There's a point where a cryptographically relevant quantum computer will be available, and we only need one at a nation state like China or North Korea to have problems with banking records that were exchanged over the internet and military reports or whatever, any sensitive information. But what about IoT? Am I concerned that my soil humidity reports from the field in 2025 are stored and then decrypted in 2035? Probably not, right? Probably not. Medical devices, on the other hand, routinely will carry the patient name, date of birth, medical condition. A little bit more of a problem, right? So if your product carries anything that could be considered sensitive information, probably should be looking into this issue. The second one is real-time access, such as, let's just conceptually, a man-in-the-middle attack being performed right now. Well, that requires a quantum computer right now. This is not a harvest now, do something later. It requires real-time access. We don't have to worry about those until about 2035. However, IoT is famous for being installed and lasting for a decade. So you do kind of have to worry about it now, too. All right, so what can you do? What are the concerns? What can you do? First of all, NIST has standardized post-quantum safe algorithms for use in things like TLS 1.3. And the people who make products that implement TLS 1.3 for the enterprises are converting over to it. Laptops and servers do not have a problem with these encryption algorithms. They are, however, a heavier lift. And if you already had TLS 1.3 in your product, don't assume that your CPU and memory footprint will handle the NIST post-quantum stuff. Actually, likely not. If you're already kind of a little bit on the edge in terms of your resources, trying to stay under a cost target with the amount of cores and memory and whatever you've got in your microcontroller, probably you're not going to be able to handle a switch over to Kyber or one of the other new algorithms. So there's some words on the slide here, but the point is NIST is encouraging research to solve this problem for lower-end devices like the smaller IoT devices, but it hasn't popped the cork yet on the champagne. Once they do get the algorithms once the algorithms are available, they have to go through a standardization process. We're probably just really grossly ballparking 3-5 years away from the point at which a vendor can say, oh yeah, we got that. Right now, the current selected algorithms, the names are on the slide so you can look them up if you want. FIPS 203, 204, and 205. FIPS 204, FIPS 205. So you can go research that, and you can talk to your vendor and see if they have something that you can use that fits those categories. Let me see how much time I have. The timer's not actually running here. Okay, I'm out of time. I am going to step outside and take questions outside. I want to be courteous to the next speaker. I want to thank you all for your time and attention. I wish I could give you a chance to speak up and tell me how wrong I am or ask questions, but thank you so much for your time and attention. Enjoy the show.